Hi everyone, welcome to my channel. My name is Fikret. In this end-to-end course, we're gonna dive into amazing world of real-time analytics in Databricks. I'm excited to take you there. Changing frequency of micro batches in stream is not only way of changing its behavior. So you can adjust certain source and the sync parameters to change the way streaming behaves. Depending of your source type, some of the common source options that you can use are following. So you can use latest first option, which is useful for file-based inputs. By default, if you have many different files in your streaming folder, it will start by the files which has earliest timestamp. However, you can change that behavior by specifying latest first option, which I'm going to demonstrate shortly. Another useful parameter when it comes to ingesting from raw files is max files per trigger. Spark Structured Streaming is very scalable and powerful technology. By default, it can process many files in parallel. However, in some cases, you may want to throttle the streaming ingestion process by specifying maximum number of files that are allowed to ingest within each micro batch. Another useful option is the rows per batch option, which allows you to adjust number of rows, especially if you are reading from delta table. Finally, there is a clean source option, which allows you to clean the input files from your source folder. There are three different flavors for this option. By default, Spark uses off option, meaning that it does not change anything in the source folder. However, you can use delete option, which will remove the files as soon as they are processed, or you can use archive folder. In that case, processed files will be moved to another folder. Let's take a look how it works. Okay, so in command 27, I have streaming from source files. However, I have added max files per trigger option to limit number of files ingested to 5 files at a time. I'm also using the latest first option, and if I run this command, you will see that the first set of rows in my data frames representing more recent data. So I have 2 days worth of data right now for January 1st and January 2nd, and you can see that it started processing from January 2nd. In command 28, I demonstrate how to use clean source option. And here I am choosing archive option. One thing to notice that if you are specifying the archive option, you also have to specify source archive dir option, indicate where your archive folder will be created. I should mention that when I run this command for data sources located within Unity catalog, it did not produce desired effect, meaning that it did not create the archiving folder, although the streaming was running fine. So I think it's likely because of location of these files, and if your source files are located outside Unity catalog volumes, this archiving option may work. If any of you guys were able to run this command successfully and create archive folder, I would appreciate if you put it in your comments. Now, in terms of sync options, we have already seen how to write into delta tables. Some other popular options are memory option. Then there are a couple of custom sync options. So for each batch method allows you to specify function, custom function, within which you can use static data frame methods to perform some operations which you normally cannot do using standard stream APIs. Examples of this could be writing into sync types that are not supported by streaming. For example, you can write in the database from foeachBatch function. Another good use case will be writing the multiple syncs simultaneously within the same micro batch. For each method works similar way, except it's on a row level. So here you can also write into some destinations not supported by standard streaming methods. However, this is going to be on row level granularity. Let me demonstrate this. All right, let's take a look at the usage of some of these sync options that we discussed. So in command 32, I have example of streaming pipeline that writes into memory. And to do that, I have specified format method, memory option, and then I have named my query, just like I did that for other streamings. Let me run this. Once my streaming has completed initialization and in a running stage, I can use this query name to browse the content of this stream. So if I run this select statement, I will get the content of the stream. Now let's talk about two custom sync types. So for each batch sync requires two components, user-defined function and the stream itself. So I have for each batch method within the stream, which refers to that user-defined function. And this user-defined function requires two arguments, a data frame and the batch ID. So data frame is the piece of data that's being passed within each micro batch to this function. And batch ID is just internal ID of this micro batch. So what I do within this function is that I apply pivoting transformation to this data frame and write the results to delta table. So pivoting is one of the transformations that is not available within standard streaming transformations. And by using foreachBatch method, I can overcome this limitation. Another example of this customization would be writing into multiple destinations. So I can have another data frame here and apply different transformation and write the results to different table. And here is how my pivoted data looks like. Another custom sync type is foreach, and it works similar way to foreachBatch. So in command 36, I have example of that where I have stream referring to a user-defined function. The biggest difference between this and foreachBatch is that this user-defined function works on a row level. In this example, I am writing content of this row to the file system as a text file. However, you can also use foreach transformation to write to some of the destinations that are not supported by streaming. Let's talk about streaming output modes. There are three output modes: append, update, and complete. Their names are self-descriptive. So with append mode, the rows in the destinations tables are only appended, so you never update the rows. So it's a great option for detailed streams, like the ones we have been building so far, where you are applying only transformations like select and mapping. You can also use it for joins and event-based aggregate systems. With update transformations, your rows in destination can also be updated. So it's great for detailed and aggregate streams. Additional advantage for aggregate stream is that it will require less memory because it usually does not keep the data which is not being updated. So we'll talk about that in more details when we discuss stateful and stateless transformations. Finally, with complete mode, the internal memory is being updated every time. So obviously that mode is not appropriate for detailed streams where your number of rows is constantly growing. This is great for aggregations type transformations where your output data size is much smaller than your input. The append mode is default mode. So that's why I haven't specified in the previous streaming pipelines. But let me go back to the memory syncs that I demonstrated earlier. And here you can see that I am using update method.